So this is a subject that I absolutely hate talking about, and that is nomenclature of organic molecules. And it's super dry, it's super frustrating, it's really detail-oriented, and there's lots of ways of doing it. So I'm not going to lecture on this too much. I think that it's really algorithmic. You need to go and learn how to do this. There's any number of sources who care about this a lot more than I do. So focus on learning this either from the book or from ochem.com or from Khan Academy, anywhere you want to learn how to do nomenclature. The reason why I care about nomenclature is largely so that we can use the same terms when talking to each other. So there are some things that I will highlight for you. The first is that nomenclature in organic chemistry is really all about the prefixes and the suffixes. The other thing I'll say about organic chemistry naming is that there's lots of ways of naming things well, usually. And so there's the IUPAC nomenclature, which is to say the really detailed way of naming things that's absolutely 100% correct. And then there's the way that people usually talk about the molecules, which is not necessarily the same. So there's two ways that we're really going to use nomenclature in the lecture. One is that I will give you a name and you need to be able to write the right structure for it. That's the easier problem. The harder problem is I will give you a structure and ask you to name it. That's quite a bit more challenging. But really where we should start is by saying, okay, what are the things that you absolutely need to have rock solid? And they are some prefixes and some suffixes. That's the way organic naming works. So let's start there. What are the prefixes that matter the most? You need to be able to count to 10 in organic chemistry. These are the terms, the prefixes that just simply you need to have memorized. So meth is 1 in organic chemistry. It means 1 carbon. F is 2 carbons. Prop, 3 carbons. Bute is 4. Pent is 5. Hex, hept, oct, non, dec. So let's count to 10 in organic chemistry. Meth is 1. Eth is 2. Prop is 3. Bute is 4. Pent is 5. Hex is 6. Hept is 7. Oct is 8. Non is 9. Dec is 10. Memorize those. You'll just simply need them. Don't get confused. Then, some suffixes that you will encounter right away. Ane means CHs, and it specifically means that you don't have any double bonds. So all of the molecules that I've drawn so far are the alkanes. No double bonds. They just have hydrogens. So this ethane molecule is 2 carbons and 6 hydrogens, 3 on each side. What are the 10 organic alkanes you need to know? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Again, prefixes, suffixes. Put them together, that's the base case for all of these. Ene is the next suffix. That implies a double bond. So this right here would be ethene, technically. Now usually people will pronounce that ethylene instead, and that's because there's almost always 2 names for any simple organic molecule. Ine, alkyne, that's a triple bond. So this would be ethyne. Ethane, ethene, ethyne. Now, of course, just to make things more complicated, this is ethane, this is ethylene, according to normal nomenclature. Ethene is proper, ethylene is the way you're going to hear it. This is ethyne, but it's also acetylene. People will tend to call that acetylene instead. Another suffix that comes up absolutely all the time would be -ol, as in an alcohol. So this would be ethanol. This would be propanol. This would be 2-propanol. Why do we have numbers associated with these? Well, you need to be able to tell the 2 different versions of propanol apart from each other. Either the alcohol can be at the 1 position of the molecule or at the 2 position of the molecule. So either the alcohol can be at the 1 position, this is 1-propanol, or it can be at the 2 position and it will be 2-propanol. How do we do the numbering? Well, big picture, you first find the longest chain of a molecule. So let's do the naming for this guy. What does it look like? Well, it looks at first as though this is the longest chain for the molecule. Hey, it's 4 carbons long. 1, 2, 3, 4. However, this can be very confusing and frustrating because the longest chain for the molecule actually starts right there and ends up being 5 carbons long. So rather than naming this as a butane, this is properly named as a pentane, and it has methyls at the 2 and 3 positions. So how would I name this thing? This would be a pentane first, and then I need to have 2 methyls bound to it. So this is going to be some version of a methyl pentane. I have two methyls, so this is going to be a dimethyl pentane. And now I need to indicate where those methyls are. They're at the 2 and 3 position. So this would be 2,3 dimethyl pentane. Again, this is really detailed, this is really frustrating, this is annoying, so I'm not really going to go into more details on how to do this. You can learn that. It's algorithmic, it's in your book. Any number of other sources will do it better than I. But broadly speaking, this is why we have numbers, because there's a significant difference between the properties of 1 propanol and 2 propanol. But just to make things confusing, it's annoying to say 1 propanol, so people will call it N-propanol, and N assumes that that is the 1 propanol. But they really do N-propanol to differentiate it from isopropanol, which is the way most people would choose to call this molecule. You may hear this done a slightly different way as well. Isopropanol is proper, but they might also call it isopropyl alcohol. Same thing. There are lots and lots and lots of prefixes that you will eventually need to know that essentially amount to functional groups, different things that you're going to see a lot of. I've already indicated a functional group here, an alcohol. That's one of the most common functional groups that you're going to encounter. Another, a similar one, is a ketone. And these R groups are telling you that I am not specifying what's at those positions, so the simplest possible ketone is 2-propanone, otherwise known as acetone. If I have the possibility of multiple places where I could put the ketone, then you need to start using the numbers again. This would be 3-pentanone. Where do you learn the functional groups that you need to know? Well, if you open the inside cover of your book, you're going to see lists of functional groups. Those are ones that you should probably just go ahead and start memorizing. Alcohols, ketones, we'll use a bunch of. Some functional groups that we're going to use a lot are the halogens, and they actually show up in the nomenclature as prefixes. So bromo or chloro or fluoro or iodo, the identity of the halogen is being specified. Meanwhile, cyclo is a prefix you're going to see absolutely all the time, and that indicates a ring. The smallest possible ring is cyclopropane, which looks like a little triangle. A little square would be a cyclobutane. Cyclopentane is a pentagon. Cyclohexane is the one that we're going to use more than any other ring structure. 5 and 6 membered rings are absolutely ubiquitous in organic chemistry. They are everywhere. So cyclopentane, cyclohexane, these are structures you're going to use a fair bit of. Cyclobutane, cyclopropane are also interesting and show up some. The bigger rings tend not to be formed nearly as much. So there are plenty of examples in organic chemistry where there's lots of ways that one could choose to name a molecule. It's a simple choice as to which one you want to use. And there's almost always going to be some older nomenclature that will be preferred over the standard IUPAC naming. With other systems, it's possible that there are multiple good ways of calling a molecule, but you need to make some choices. You need to decide whether this molecule is a benzene or a toluene. You need to decide if this molecule is a propane or a cyclohexane, and so on and so forth. This molecule, though, is where I wanted to start, and it is a propane, fundamentally, because the longest chain is 3 carbons. And so one way of representing this might be to call it 2-chloro-2-methyl propane. But that's a mouthful. Almost everyone would prefer to call it tertiary butyl chloride or T-butyl chloride instead. You should be aware that tertiary butyl simply refers to this arrangement. You should be aware that an isopropyl looks like that. Those are the ones that will show up more than any other. If you hear tert-butyl, it means that. If you hear isopropyl, it means that. If you hear sec-butyl, it stands for secondary butyl, and what it implies is that. This is secondary butyl, S-butyl. How should we name this molecule? Well, if I call it a cyclohexane first, then this would be isopropyl cyclohexane. Isopropyl cyclohexane implies that the parent is a cyclohexane, and it's an isopropyl coming off. The other way that you could describe this is as a cyclohexane that has a 2-propyl coming off, but almost everyone will call it isopropyl as the side chain as opposed to 2-propyl. But we could also number it this way and say that this is a propane that has a cyclohexane group coming off the 2 position. So this would be cyclohexyl, 2-cyclohexyl propane. Which of those options is preferred? They are the same as far as I'm concerned. there's no real advantage. If I'm interested in the ring, then I'm almost certainly going to call it a cyclohexane. If I care more about the propane part, then the cyclohexyl is the boring side chain. It all depends what I'm trying to communicate. But the reason why I've highlighted this molecule for you is because you could choose to name that two different ways as well. This is a benzene ring, so the parent here is going to be benzene. However, I also have 3 nitro groups on this benzene, so I'm clearly going to have a trinitrobenzene. If we define this position to be the 1 position, then the nitros are at 2, 4, and 6, so this is going to be 2, 4, 6 trinitrobenzene. And I have a methyl at this position, so this will be 1-methyl 2,4,6 trinitrobenzene. No one is ever going to call it that. Instead, what they're going to call it is, it's a toluene. The methylbenzene part has its own name. So this is instead 2,4,6 trinitrotoluene, otherwise known as something that goes boom, TNT. Again, the message that I have is that nomenclature is complicated to do. It's frustrating. You need to devote time to it. It's very detail-oriented. You need to practice. You may have noticed already that what I'm always doing is identifying the parent and then adding things to the parent as you go. I strongly advise you do that. When you go to write down a name, start writing at the end. Toluene is the parent. Everything else is off of that. Or, if I'm going to call it a benzene, then this becomes all the prefixes. If I call this a propane, I start with the propane, put the cyclohexyl on the front. This is cyclohexane, then I have a nice propane coming off. There's another set of prefixes that we should talk about when it comes to the naming of the side groups. I've already started to do it by calling this a trinitro, and I previously did it with a di for the methyls. So these are the prefixes that you want to use when you're talking about putting substituents onto a main chain. Said another way, if I have some major group, if I have a benzene ring, then anything that's coming off of this ring is going to be a substituent. So this would be a trichlorobenzene ring, and if I put 2 other substituents on this might be a difluoro-trichlorobenzene ring. Because of the need for alphabetical order, of course, the right naming for this would be trichloro-difluorobenzene. And then I would need to define which one of these was the 1 position, starting there, 1, 2, 3, trichloro, 4, 5, difluorobenzene. The prefixes that you need to use for substituents, the things that are coming off the parent chain, are mono for 1, although usually you can omit it. Obviously there's no reason to say mono if there's only 1. Di, tri, tetra for 4, penta for 5, and then these I have for completeness, but almost always you won't need them. When we're talking about substituents coming off, you're going to use di and tri a lot, tetra occasionally, and it starts being unlikely that you will use the rest of the prefixes for your naming. Again, there's no way to get better at this without just simply practicing. So practice your nomenclature. Promise it gets easy. Practice your nomenclature, and I promise that you will be able to use this in the way that I want you to. It never becomes easy. In fact, practicing organic chemists will frequently rely on ChemDraw to do the naming for you, because as soon as you become able to talk competently about your molecule, then this is information that you always have in the back of your head, but you don't necessarily worry about generating the proper IUPAC name for anything in particular.